Good evening, everyone. Um, Good evening, dear participants. Good evening, esteemed speaker. Today, I welcome you all on the fifth day of our workshop. I am Shikha Mudgal, and today we will be discussing the chi-square test, remaining parametric and non-parametric measures. So, over to you, sir. Ashok, sir.
Thank you, ma'am. Thank you. Thank you, ma'am. And good evening, all participants. So without wasting time, I'm sharing my screen. So is it visible, ma'am?
Uh, mm, Right. Yes, sir. Your screen is visible, but your presentation is not yet.
Yes. I'm opening my presentation. So my PPT is visible now.
Yes, sir.
Okay. So today it's day 5, and we will do inferential statistics, which we have left non-parametric test, Mann-Whitney, Wilcoxon, Kruskal-Wallis, with post-hoc analysis for multiple comparisons. Chi-square test or Fisher-Exact test, Pearson and Spearman's correlation coefficients, scatter plot. So when we do correlation coefficient, we need scatter plot also to represent our data graphically, then simple linear regression and multiple linear regression. So today I request all of you that I think we have 1 day behind, okay? One session behind. So today I'll take classes up to 7:30, okay? And if you have any question, you can write down, we will discuss tomorrow, because I have to complete this task, this session. So this is a very famous slide, parametric versus non-parametric. We have discussed about this, okay? So what happened, because you can see here in this dependent variable is quantitative, 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 and quantitative, okay? And you see that if this dependent variable is normally distributed and there are two groups, dependent variable is quantitative in nature, there are two groups, independent groups, control and intervention, we should use to compare means, independent or unpaired t-test. If this quantitative variable is not normally distributed, we have to use a Mann-Whitney U-test. Okay. And this is same group before and after or pre and post. Dependent variable is again quantitative. Then we use dependent paired t-test, dependent or paired t-test to compare before and after mean comparison. And if it is not normally distributed, we should go for Wilcoxon signed rank test. And there are more than two independent groups. For example, control group, treatment A group, treatment B group. Okay, more than two, 4 group, 5 group. Sometimes we can encounter these groups if we have more than 2 groups. Okay, dependent variable is quantitative and it is normally distributed one way ANOVA. If it is not normally distributed, Kruskal-Wallis. If our independent variable also quantitative and dependent variable is also quantitative, and if we are for this, in this condition, we have to do correlation coefficient. One variable is increasing, okay? So what about other variable? It is increasing or decreasing, okay? There is a relationship. It may be positive or negative. So if these both quantitative variable normally distributed, we should go for Pearson. Otherwise, we should go for Spearman rank correlation coefficient rho. Okay. So what happened if our dependent variable is not quantitative? You can see here dependent variable is quantitative, 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 and these are the tests. If parametric or non-parametric. But what happened if our dependent variable is not quantitative? It means our independent variable is qualitative or categorical, and also our dependent variable is qualitative or categorical type. Okay, so what happened and which test we have to use, we have to apply. So this is chi-square or Fisher exact test. That is CCC. CCC means independent variable is categorical, dependent variable is C, that is a categorical. Okay, first C means independent variable is C means categorical, and second C is dependent variable is categorical or qualitative. Okay, so what is third C? Third C, use chi-square. C means chi-square. Okay, so these are the another scenarios for chi-square test. If there are 2, 3 or 4 independent group, that is these are the independent variable. Okay, and the nature is qualitative or categorical variable. It may be 2, 3 or 4. And our dependent variable is also qualitative or categorical. For example, mortality, yes, no. Hypertension, yes, no. Male, female, yes, no. Alive, death, yes, no. Disease present, yes, no. Absent, present, absent. Okay, and disease symptoms mild, moderate, severe. Or these qualitative or categorical dependent variable is more than 2, like 3 category, 4 category, 5 category. So we have to use a chi-square test oblique Fisher exact test. It's a distribution free test because it is in parametric or always is non-parametric. Okay, so we can use it because qualitative data we cannot check normalcy. So there is no need to check normalcy, what is parametric in condition, what is non-parametric. It's a direct chi-square test or Fisher exact test. Where we use chi-square, where we use Fisher exact test, I will tell you. Now one situation more, that is a same or one group means within group. For example, before and after, pre and post. Comparison of baseline to follow-up. Comparison to baseline to follow-up. Comparison to 3 month to 6 month. Within group, same group. So if a dependent variable is binary outcome, for example, pain, yes and no, any condition in the form of yes and no, present and absent. Binary means two, dichotomous. So we should use for McNemar test, only McNemar test. If the independent condition is same within group before and after, but here in dependent variable there are more than 2 categories. For example, disease symptom, mild one, moderate 2, severe third. There are more than 2 categories. Okay, it may be 4 category and 5 categories. So here independent variable is qualitative, here dependent variable is qualitative. So we have to go for McNemar-Bowker test. Okay, so and for quantitative and quantitative, we know Pearson. In the case of parametric and non-parametric, it's a Spearman. And when our dependent variable is quantitative and our independent variable is quantitative and dependent variable is also quantitative, only one variable. And if we want to predict quantitative variable due to independent variable, okay, dependent variable, if you want to predict dependent variable, okay, dependent variable due to independent variable, so we have to use simple linear regression if our data is not normally distributed. But this test is k nearest neighbors, KNN regression, if these both dependent and independent variable are not normally distributed. We will discuss later on about this. Next is if our independent variable is quantitative and okay, I think there is some correction here. So what you have to write here, you have to correct it. Our dependent variable is quantitative, okay? Our dependent variable is quantitative and only one variable, okay? But our independent variable here, please see, in case of multiple linear regression, please see if our independent variables is maybe it quantitative or qualitative or categorical, more than one variable. So please like shift this sentence from this cell to this, and is this quantitative is from this to this. Please write, please read according to this. There is some mistake, okay? So you can understand it. So it means multiple linear regression means there is one dependent variable that must be quantitative, but there are more than one independent variable. There are more than one independent variable, and these independent variable may be quantitative or may be qualitative or categorical. Okay. So now we will use this chi-square or Fisher-Exact test. You can see to find out a significant association between independent and dependent variable. Association between one and second variable. That is, one is independent variable and second one is dependent variable. For example, association of smoking with lung cancer. Smoking yes, smoking no. Lung cancer yes, lung cancer no. Both are categorical variable. Association of age with hypertension and diabetes. Hypertension and diabetes is categorical. Okay, hypertension yes, hypertension no. Diabetes yes, diabetes no. But what about age? Age is we know that it is a quantitative. But if you want to use this chi-square, or if you have age category 10 to 20, 20 to 30, 30 to 40, 40 to 50, like this, then you can find out, you can use chi-square or Fisher-Exact test, and you can find out significant association. So here age is not in the case of chi-square or Fisher-Exact test, and here is association. It means age is not exact age, quantitative. It is categorical. You have to think. Okay. For example, write down, like for example here, association of BMI with hypertension and diabetes. Okay. So you have to think it is not BMI is quantitative variable. Okay. Exact variable. This is category of BMI. Okay. Now association of gender with HB level or anemia. Anemia yes, anemia no. And gender we know that is categorical, male and female. Okay. So it might be transgender also, but this is categorical variable. Okay. So you can like this, you can see this table and you can understand more about this. So association of smoking with lung cancer. You can see here in this lung cancer and no lung cancer, n is equal to 54%, n is equal to 46%. Here smoking and no smoking. So we can see here in smoking, who are smokers have lung cancer 41. Okay, out of 100. You can see this is a total 100 participants. 41 has smokers has lung cancer, and only 14 smoker has no lung cancer. Okay, and then no, in the case of no smoking, lung cancer has only like 13 patients who are no smokers, but who are no smokers, no lung cancer at 32 out of 100. And these are the percentage you can see. Total here from 54, 41 out of 54, this is 75.9. And 13 out of 54, this is 24.1. These are percentage. You can, it is called column percentage. You can calculate row percentage also. Out of 55, you can calculate 41, and 14 you can calculate. Okay. So here one thing is coming. You can see here degree of freedom in chi-square test will be calculated using this formula. So degree of freedom for chi-square test is number of rows minus 1 into multiply by number of column minus 1. So this is a degree of freedom formula in a chi-square test. You can see here there are how many columns here? Column 1, column 2, column 3, and column 4. Okay. How many rows here? 1 row, 2 row, 3 row, and 4 row. So please don't consider according to this. You have to count only rows and column number where data is over there. Okay. Only data. Please don't count total and total row and column. Only data here. So where is data? Data is here. and this is here, and this is here, and this is here. Only 4 cells have data. You can see here. So how many rows? This 1 row and 2 row. And how many column? This 1 column and 2 column. So it is a 2 column, 2 row. It is called 2 by 2 table. It is also called contingency table. So 2 by 2 table is also called contingency table. Please remember. So we can calculate degree of freedom. Number of row minus 1. Number of row are 2 minus 1. Multiply by column are 2 minus 1. 1 multiplied by 1 is equal to 1. So degree of freedom for 1 for always for 2 by 2 table. Always for 2 by 2 table. Degree of freedom 1 in chi-square test. Please remember this. Okay. Now correlation coefficient R or rho. R means Pearson correlation. Rho means Spearman rank correlation coefficient. To find out relationship or direction between two quantitative variable. If both quantitative variable are normally distributed, go for Pearson correlation. If like any variable, any quantitative variable or both quantitative variable are not normally distributed, go for Spearman rank correlation coefficient, in which one is dependent variable, that is quantitative, weight is quantitative, and other one is independent variable, that is also quantitative. Okay, it may be qualitative also, but in this case I have given example of quantitative dependent variable and quantitative independent variable. On y-axis always is dependent variable, okay, and in on x-axis it is independent variable, and its value is -1 to +1. Please remember, value always must be between -1 to +1. And when you calculate and you got this value r is equal to plus 1.12, so kindly interpret it, because it is more than 1.12 plus 1. It is more than +1, that is 1.12. It means it is not correct, it is wrong, because we know r value is must be between -1 to +1. So it is 1.12, it means it is greater than +1, so it is wrong. Okay, there is something wrong in calculations. So we can see here it is a perfect positive correlation. There is a straight line. It is called a scatter plot. There is a strong positive. There is a scattered points. You can see this is a weak positive. There is no correlation over there, and this is a perfect negative, like this. This is a strong negative. Okay, there are some scattered and weak negative. There are more scattered points. In x-axis there is an independent variable, and in y-axis must be or always dependent variable. So height is here and weight is here. Okay, in this case. So, and this is a beautiful slide, I think, for R. If it is like plus 0.70 or higher, we can say very strong positive correlation. It is 1, it means perfect positive correlation. Then we can give, if for example, it is value is plus 0.012 plus 0.19, it means no or negligible relationship. There is a positive correlation, negligible positive correlation. If it is 0, r is equal to 0 means though no relationship, means no linear relationship. And according to this is a negative also. We can say weak negative, strong negative, and very strong negative. If r is -1, it means perfect negative correlation. Okay, between height and weight, or between any variable, BMI or HB level. Okay. And this is most important thing. I think we will get it. R square. It is called coefficient of determinant. So R square, when we do correlation or regression, we will get it. R square is a measure. R square means R correlation coefficient R. Okay, square of that R, that is R square. It is called coefficient of determinant. So R square is a measure of how well a regression model fit the data. It represents the percentage of variation in one variable that other variable explain. Here one variable is dependent variable and other variable means independent variable. For a pair of variable means dependent and independent variable, R square is simply the square of the Pearson correlation coefficient, as I told you. For example, squaring the height weight correlation coefficient. Suppose we got height weight correlation coefficient is R is equal to 0.694. So R is 0.694. So R square is square of this 0.694. You can square and you can check. So it came 0.482. It means we have to convert it into percentage, that is 48.2 percentage. So we can say height explains about half, nearly half, that is 48.2% of the variability of weight in the study participant. It means weight is dependent, okay, or we can say it like this: weight is changing, okay, 48.2% variability due to height. We can say according to this. Now, simple linear regression, to predict the change, first we have to do correlation. Correlation means relationship and direction, negative and positive. And relationship means weak, moderate, okay? And we can see high, and we can see perfect. This is like a degree of relationship. And direction means negative or positive. To predict the change in quantitative dependent variable means weight by change or manipulation in quantitative independent variable, that height. So first we have to do correlation, and if there is a significant in correlation, then we can do linear regression. And it is for the prediction of a quantitative variable, that is a dependent variable, due to change or manipulation in independent variable. It is extension of the Pearson's correlation coefficient. Okay, very good. And it is applied to understand relationship between variables, evaluate trends, and make forecast, means prediction for the sample population. If we increase height by 1 centimeter, so what will be weight? Okay, it is a forecast or prediction. So suppose we get in simple linear regression, we will get a equation, okay, mathematical equation. So due to mathematical equation, we can predict or we can calculate weight according to height. Okay, so minimizing the, you have to remember this, minimizing the sum of squared error can be understood as the finding the best fitting straight line through the example points. Means regression is a line, okay, in scatter plot, and this is best fit line. And is the nearby this line, there are actual data or observations, okay, and these observations are far from this line, okay, nearby this, around this line. And when we calculate their difference and square their difference, and we add this difference, it is minimum. It is minimum. It is called best fitting straight line. And best fitting straight line is called the regression line. Okay, so you can see here, this is x explanatory variable, that is a height here, height, and y is a regression response variable or dependent variable. X is independent variable, y is dependent, that is a weight. You can see this is blue line here, this is a regression line. Okay, this is a regression line. And these are the scatter plot. Okay, for example, here one participant height here, and this is weight here. So we point out here, okay, we do point here. then software will do automatically. This is for second participant, this is for third participant, height and weight. Okay, height and weight. And this is a best fit line. Why it is best fit line? Because these are actual observations, and these are the distance, okay, from this best fit line, you can see here. Okay, and when we square these distance and sum this distance, so if we like draw other line here, okay, maybe this line, maybe this line, so this line, the sum of square is minimum. It means there is a minimum error. Okay, so what do you mean by intercept here? You can see here, please understand this, it is an intercept. So what do you mean by intercept? Intercept we call this regression line is cut, break the y-axis on when x is equal to 0. So where at what point this regression line cut or touch the y-axis on x is equal to 0. Okay, here x is equal to 0 and these are its increasing x. So here this is a x is equal to 0. Always it is x is equal to 0. And this regression line is cutting this y line, y axis. So it is called a intercept. Okay, so here is the value of y. For example, 5, 10, 20, 15, whatever. So it is a 15 is a intercept. And what is slope? You can see there is a slope in line. You can see here. So what is slope? Slope is delta y divided by delta x. So what is a delta y? You can see here from this point to this, we can say here slope. This is from here to here. So what we see this is a delta y. Here y you can see this is point, this is y, and there is also y. So the difference between these 2 points, that is delta y. So what do you mean by delta x? From here this is x and also there is a x. So x from we have to minus this x to this x. Okay, this is x1, this is x2, suppose. So x2 minus x1, that is delta x. And when we divide it, delta y divided by delta x, it is called slope. And this is equation of linear regression. So y is dependent variable. For example, weight, you can see weight is equal to W0. W0 is intercept. So it is always constant in this equation line. Plus W1. W1 means this is a slope. Okay. And this is x. X means independent variable, that is a height. So this is y is a height, weight is equal to constant intercept plus slope into height. So this is equation. When we do in SPSS analysis in SPSS, then we will make this equation. Okay. So you can see here in simple linear regression, equation is y is equal to a plus bx plus epsilon. Okay. So here epsilon is a random error. So there is some random error in statistical language. So we have to write down plus epsilon, that is a e. And when we calculate it in actual, then this time we ignore this plus e or epsilon. Okay, this is a random error. So where y is a dependent variable, for example, hb, here hb, x is an independent variable, for example, age. So we want relationship between age and hb. Okay, a is an intercept, as I told you, when x is equal to 0, and this point, at what point regression line cross the y line, and b is the slope of the line. So here a and b, over there w0 and w1, same thing. Okay, so b is equal to delta y divided by delta x. Okay, this is multiple linear regression equation. Multiple linear regressions means there is one dependent variable, but independent variable is more than one, or these independent variable may be quantitative or may be categorical. Okay, So where y is dependent, or this is a equation, okay? Y is equal to a is a constant, plus b1. B1 means like slope of x1 variable. B2 plus B2. B2 means slope of x2 variable, plus B3. B3 means slope of x3 variable, and plus dot 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 plus epsilon means here E is a random error, and for calculation we can ignore it. Where y is a dependent variable, for example SB, x1, x2 and x3 are independent variable, for example gender, age or height. And here in simple linear regression only HB and age, and here in multiple linear regression HB is a dependent variable, but independent variable age, BMI, height, okay, systolic BP, we can take anything, okay. A is a intercept, and B1, B2, B3 are slope of the line of x1, x2, x3, okay, you can see here. So let's have fun with SPSS. Both dependent, please remember, both dependent and independent variable are qualitative or categorical. Both dependent and independent variable are qualitative or categorical. Which test we should use? We should go for chi-square or Fisher-Exact test. C. Both dependent and independent variable are quantitative. Use Pearson correlation coefficient if both variable are normally distributed. Otherwise, use Pearson Spearman's rank correlation coefficient. To predict HB level on age of the participant, only dependent variable is HB level. That is exact, okay, exact values. On age is also exact. So we have to use simple linear regression. To predict HB level on age, gender, height, weight of the participants, we can see here our dependent variable is only HB, but independent variable is more than one. So it is called multiple linear regression, okay? Thank you. So first we will do, I have opened. I had a mistake with some 30 like SPSS because you are a lot of participant facing. So I download 25 and I'm doing on this analysis 25, same similar findings. Most of the things are similar. So first, Mann-Whitney U test. Okay, I'll show how to do Mann-Whitney U test. So there is one categorical variable, two groups. Okay, and dependent variable is quantitative, and that quantitative variable is a normally distributed or not normally. That is a not normally distributed. Suppose I want to check two groups. Okay, two groups. There must be two groups. Okay, so I have make these two groups. When I use more than two group like one-way ANOVA or Kruskal-Wallis, I will use this. Okay, and when I do only for two groups, I will use this. This is hypothetical data. Okay, so don't worry, this is hypothetical data. Okay, I'll do this. So what I have to do, I have to click this analysis. Okay, I have to click this analysis. Then where I have to go? I have to go non-parametric test here. And for T test, something like that, I have to go for compare means, or if I have 30 version, compare means and proportion. Okay. So this is the test, independent, paired, and ANOVA. For non-parametric test, I should go for this. I have to click on legacy dialog, non-parametric, analyze non-parametric legacy dialogues. And there are two independent group here. You can see here, this is a two independent sample. Okay. There is no name of Mann-Whitney and Kruskal-Wallis and Wilcoxon. These are the names you will find out here. So you have to think there are two independent group. For non-parametric, click here. This is dialog box. Now you can see it is here in test type. There is a Mann-Whitney U. Okay, in this you can see here. So what I have to do, I have to like HB. Okay, HB. So in test variable, I have to enter HB. So this is HB. Okay, I can enter this HB base, HB third month, or HB 6 months. So I'll enter all three. So I have to click HB base and then this arrow. Then HB 3 month and this arrow. And HB 6 month, I have to click and then this arrow. And in grouping variable, I have to enter group. Okay, group 2. Okay, group 2. So where is group 2? Oh, there is no group 2. So I think there is some mistake in this. And why there is no group 2? I have to see here. Oh, this group 2 is, you can see here in string type of variable. And this man, Whitney or non-parametric are not apply on this string type of variable. So what I have to do, I have to code it. Then I can use it. So how to code it, I will show you again. So cross it, then another way, second way, how to code it, I will tell you. So what is it? You have to click this transform button. Before analysis, there is a transform button. Click this transform. And then you have to click this record into different variable. Please, and please never click this record into same variable. If you click it, the code will be appear in this variable here. But we want to keep this variable group 2 here, and we want to code in different variable. So please click this record into different variable. Click this. This will come input variable, output variable. So what is my input variable? Group 2. So click group 2 and then click this arrow. Then what you have to do? You have to give this output variable name here. Okay, click here. Give group 2 code. So I have coded it. So I want to give name this group 2 code. If you want to give label, leave it. There's no need to give this label. Then click this old and new variable. So please click this old and new variable. Very good. And this is recode into different variable, old and new values dialog box. So please click here value, old value. We have to remember exact spelling of that variable. Okay. So this is a spelling. It is in uppercase, lowercase, whatever sentence case, we have to type exactly. So what I have to do, I have seen that this is a control group and this is in all words are in capital. So I have to write down control space group. And then I have to give value 1. Okay. And I have to click add. So this is a control group of 1. Then I have to click again value 2. I want to give code 2 to intervention group. You can give vice versa also as you wish. 2. So old value intervention group. Sorry. So I have to check spelling. I is capital. All other words are small. So intervention and group G is also small and there is a space. I have to give value 2 in new value and then click add. Okay. Then click continue. Okay. And yes, one major thing, because this OK button did not highlight. So what we have to do? We have given output variable is group 2 underscore code, but we have to click this change here. So when you click change here, this group 2 output will come here. You can see this came here, group 2 output, group 2 underscore code. Then this OK button highlighted. Then you click OK. So this you can see here. And these variable, if you decode in different variable, always will come last of a data sheet. Please remember. So this is a group 2. You can see here. This is a group 2. Always last column. You will get it. But these are the 1 and 2. I want to decode it. 1 and 2. So I want to decode it. 1 is control group and 2 is a intervention group. So I want to decode it. One is control group and two is intervention group, like that. So what I have to do? I have to click variable view. Then where is my group code here? Then in value, I have to click this none, and this is like 25 version, so you will get this. So I choose this because many participants have 25 version or below 30 version. So this dialog box will come. So in value, I have to write down 1, and I have given 1 to control group. So it is calling coding and decoding. Click add. Then 2, I have to give intervention group. Intervention group. Then click add. Okay. Then okay. Then this is a data view. Okay. We have now apply Mann-Whitney. So what I have to do? Analyze non-parametric legacy dialog and then 2 independent sample. Click this. You will get this. Then you can see below this is a group code you find out because I have coded it. Okay. So I want to see this difference of HB between 2 groups. So HB base, shift down arrow. Okay. And then I have to click this arrow. Then click in grouping variable. I have to put this group 2 code. So select it and then click this arrow. And you have to define group. You have to remember what code you have given. I have given 1 and press tab. 1, type 1 and then press tab. This cursor will automatically come down and press 2. Okay, then continue. Tab, press tab. Okay, then okay. So this is my Mann-Whitney outcome. So it is called mean rank, sum of rank. This is N, this is a control group, this is an intervention group, you can see. And this is a Mann-Whitney U value for HB base, HB 3 month, HB 6 month. This is Z value if you want to write down in your manuscript. Okay, and this is asymptotic significance two-sided. This is P value. So you can see here for HB base at baseline HB, P value is 0.494. It means there is no statistically significant of like at HB baseline between control and intervention group when we use Mann-Whitney test. And in HB 3 month, there is a statistically significant, very good. And at HB 6 month, it is also statistically highly significant. The P value is a 0.000. You can write down 0.001 also. It is highly significant. It is not less than 0.05. It is less than 0.001. It is highly significant. But for Mann-Whitney test, what you have to do, you have to present your data in median and IQR when you present Mann-Whitney test. Okay. So what you have to do, you have to calculate median and interquartile range for dependent variable, or here dependent variable is HB baseline, HB 3 month or HB 6 months for control group and for intervention group. Okay. So, and in control group, there are 75 patients and in intervention group, there are 75 patients. So I will calculate median and interquartile range. So how I calculate for this? I have to click analyze. I have to click descriptive. I have to click frequency. I think I hope you remember this. Then where for what I have to calculate median HB base, shift down arrow, and then I have to put or I have to drag these values from here to here. Then in statistics, here you can see there is a statistics button. You have to click right side, there is a, on top, you have to click here, and then you have to click a quartile in percentage here, frequency statistics. And then here you have to click minimize and maximum, and then you can click median. If you want to get mean and standard deviation, you can get. There is no problem, but I don't want to get here. So just click quartile, median, minimum, and maximum, and click OK. Please don't use this display frequency table. Please declick. Here, no need of this. Then click OK. Then this is a median and IQR. but this is median of IQR 150 patients combined, but I want 75 and 75 for control and for intervention group separately. So there is a one function in SPSS that is called split file. Split according to control group and according to intervention. And again, I will do this analysis. Then I will get separately median and IQR. How? Please remember, this is, please see here, this is data. Okay. Here, left upper side, this is a file, edit, view, and data. So you have to click data button and you can go here and you can see here, this is a split file. So you have to click this split file. This dialog box will come. So how, for what I have to split file? I have to split file according to group. So what I have to do? Where is group? Just below. Okay, in last there is a group. So I have to click this, but it is not activated. Right side is not activated. So what I have to do? Please always click on organize output by group. You can click compare group, there is no problem, but I prefer this organize output by group. So click this group 2 code and then bring this group 2 code here. So for which variable you want to split, you have to bring this variable here. It must be always qualitative, categorical. Okay. So click OK. So it is splitted. Okay. By group. Then again do this same analysis of median and IQR. So no need to go analyze. There is also one button in SPSS. This is recall recently used dialogues. Use this. It will make like easy. Okay, your work easy and fast. So click here. These are the last 10 commands you can see here. You have to click frequency, okay, because we want median and IQR. So click frequency. This dialog box automatically come. There is no need of this. If you want to click statistics, all are selected. There is no need. If these are not selected, you have to select, you have to check, continue, and okay. Now you can see it is a control group. This is for intervention group. 50, 75, 75, 75. This is HB base. This is HB 3 month. This is HB 6 month. And this is for control group. You can see median, 50th yani median, and 25th and 75th are quartile. Okay. In previous classes, we have discussed. So for control group separate and intervention group separate. Very good. Now you have to report it. Which is significant. 3 months and 6 months are highly significant, but baseline comparable. There is no significant difference. You can see here in control group, median HB is 12.9 gram per deciliter. And in intervention group, it is 12.8, approximately similar. There is no significant. But you can see here HB 3 month and HB 6 month, you can see there is a significant difference in median. Okay. Now go for before and after. I want to compare baseline and 3 month HB, or baseline 6 month HB, or 3 month and 6 month HB within group. So for within group, again we have to do split file because we have already done. So there is no need to do split file. We have to directly apply before and after test, that is paired t-test in case of normally distribution, Wilcoxon signed rank test if the dependent variable is quantitative dependent variable is not normally distributed. Okay, so we have already split, so there is no need to do again split. So what we have to do, we have to click analyze. Okay, then non-parametric, again legacy dialogues. So for non-parametric test, you have to always use this analyze, non-parametric, legacy, and this is a K2 related sample. This is a pre and post. These are related. These are pair. Pair means related. Okay. So you have to click this two related sample. We have already split files, so no need to do split. Otherwise, you have to split if there are 2 groups or 3 groups. If there is a single group, okay, there is no need to split. You have to directly apply this test. You have to remember this, okay? So this is a dialog box of, you can see here, this is a Wilcoxon test type. This is a Wilcoxon. Then you directly go for, where is HB? So I want to compare 3-month and baseline difference. So I have to click this HB3. I have to put here, click this. This is a variable 1, variable 2. You can see like similar to Patty test, okay? Click this HB 3rd month will come here. Then you have to click HB baseline, and then you have to click this arrow. This will come here. If you want to do for HB 6 month and baseline, you have to click this arrow. Then HB baseline, you have to click this. So you have to complete this pair. Okay, there are 2 pair. Pair 1 is 3 month and baseline. Pair 2 is 6 month and baseline. If you want to calculate from 6 month to 3 month, you can do here. Okay, all pair we have done. You have choose Wilcoxon. No need to do anything else. You have to just click OK. This is a mean rank. You can see here. And then this is for, you can see here, this is for control group. You can see, okay, this is for control group. And this is a test statistics. This is Wilcoxon value. You can see here Z value for all pairs. And this is a P value for all pairs. You can see here P value for HB baseline to 3 month, or HB baseline to 6 month, HB 3 month to 6 month. These are the P value. You can see in control group, there is no significant difference. But you can see here, this P value for 3 to 6 months, there is a P value 0.073. So if you find P value less than 0.1, it means there is a trend of significance. Okay, you can write down there is a trend of significance if P value less than 0.1. In intervention group, you can see here. Okay, you can see, just you have to see. So there is a difference between, significant difference in P value. You can see highly significant from baseline to 3rd month and from baseline to 6 month. But there is no significant in a base 3 month to 6 month. You can see these P values. It means in intervention group, there is a significant improvement in HB at 3 month from baseline and at 6 month from baseline. But there is no improvement from 3rd month to 6 month. So we have to write down. For Wilcoxon signed rank test, you have to present value in a median and IQR. So you have already calculated median and IQR here. So you can use this median and IQR. So this is a Wilcoxon signed rank test. Last test is for Kruskal-Wallis if there are more than 2 groups. And we will do for HB baseline, HB 3 month and HB 6 months. So we will do, for example, HB 3 month or 6 month or for all. So for this, we have to stop split first of all. Okay. So what we have to do, we have to use this shortcut method. Click here. Then this is a split file. You can see. Click here. Then what we have to do, we have to click analyze all cases. Do not create group. So please click this and then click OK. Please click where we were here. So we have to click this analyze all cases. Do not create group. If you want to create, if you want to split the file, we have to click here. Otherwise, we have to click here to stop split file. Then click OK. Split file end. Okay, there is no split file. Now I will apply Kruskal-Wallis test. So for Mann-Whitney and for Kruskal-Wallis, there is no split file if you have groups. And for Wilcoxon and Patty test, you have to have a split file. You have to do a split file first. Okay, if you have groups and you want to do analyze within group. So click analyze. Again, this is a non-parametric, then legacy dialog, and you have, this is a K independent samples. K means more than 2 independent samples, more than 2 independent groups. Okay, so click this and this dialog box will come. Test for several independent samples, more than 2 ke liye, okay, for more than 2. So I have to do for HB baseline 3 months and 6 months. So I have to bring this here for test variable, okay, test variable list. So where is HB? These are the HB. I have to click. Then I will not say what I'm doing. You have to think and you have to do. Then this is a grouping variable. So if there are more than 2 groups, I will choose this. So I have to make one group third. Okay, group third. Group 2 is only 2 groups. Group third is 3 groups. I have made in SPSS. I will search, but there is no any group. Why? I have to see first. So cross it. Then I have to go in data variable. So click below analyze. This is a star. So where is group? Group third is I have written in for like third, fourth column. Again, because this is group third, there is no coding. So due to this, it is not showing in a like a critical value. So what I have to do, I have to create coding. So again, I will repeat it. It's a very good thing. So what I have to do, I have to click transform. I have to click record into different variable. Then this is, I have to reset it. Okay, I have to reset it because I will do for another variable. For group third, I have to click this. Then I will bring this from here to here. This is our like input variable, output variable. I can say group third code. Then I have to click change. Last time I forgot to do this, but right now I will do this change. Then where I have to click old and new values. Then in old value is control. But please remember, same spelling alphabet must be here. Otherwise, it will not create or not decode the for this group. So I have to see control group is on like capital. So control group value, I will give 1. You can give 1, no issue. Okay, click 8. Then number 2 is I think diet group, DIET, diet group. You have to write down. You have to see spelling. Then new value you have to 2. Okay, I want to give 2. Click 8. Then third is I think DIET, diet and yoga group. I think I will not see. I just remember that I have given this. So click third. If you want to see, you can see here. Then click add and click continue. Then click OK. So where you will find out last. Okay, last of this Excel sheet. So please see this. Okay, very good. I got it. 1, 2, 3, 1, 2, 3. Very good. I got it. Then again, I have to decode it. But I will not say how to decode because you must, I think you have learned it and you do yourself. I will do with this. I know that what is 1, what is 2, what is 3. So what I have to do, I will go for, there are 3 groups, more than 2. I have to go for critical values test for non-parametric. Otherwise, one way ANOVA. Click analyze, same non-parametric, then legacy, then K independent samples, means more than 2. Click here. I think I have shown this. Then where is HB? These are the HB. Click, click, click. Then bring these here. Then this is a group 3 code I have given. Okay. Then please bring this group 3 code here, grouping variable. Click here. Then you have to define range. Click here. And what is range? I have given 1, 2, 3. So range is 1 minimum and maximum is a 3. If suppose if I given 0, 1, 2. So minimum is 0, maximum is 2. So please remember. Then click OK. Then what I have to do? This is test type critical values test. Okay. Just click OK. So what I have to got, you can see here, total 150 patient, 50 in each group. There is no missing. You can see here baseline. These are the group 1 to 3. And this is Kruskal Wallis values. These are the degree of freedom. Group -1. There are 3 group, -1, 2, 2, 2. This is P value. So at HB, there is no difference between among groups, between not among group, there, because there are more than 2 groups. At HB 3 month, there is a significant difference. HB 6 month, this is also significant difference. So Kruskal Wallis test hypothesis, we have to remember. Alternate hypothesis, we have to remember. And what is this? At least between 2 groups, there is a significant difference. At least between 2 groups. But here there are 3 groups. So between 1 or 2, 1 or 3, or 2 or 3, we don't know. So for this, we have to use post hoc comparison, multiple comparison, and very famous is a Bonferroni test for post hoc multiple comparison. This is called multiple comparison. 1 versus 2, 2 versus 3, 1 versus 3. It is called multiple comparisons. So there is a adjusted p value. Okay, these are not adjusted p value. These are only saying that there is a significant difference. But between 2 groups, which 2 groups? We don't know. So we have to go for multiple comparisons. So please see this. It is very important. How to do multiple comparison in case of post hoc analysis in Kruskal Wallis. So click this analyze non-parametric, and please remember, you have to click this time independent sample. Okay, you have to click. Please don't go in legacy dialogues this time, because we are going to apply post hoc multiple comparison Bonferroni. So we have to go for independent. These are the independent samples, we know. Okay, these are not related samples, before, after. No, it's a group 1, group 2, group 3. These are the independent. So we have to click this independent sample. This dialog box will come. I think this is a different dialog box. Okay, so what you have to do, this is a non-parametric test of or more independent samples. So I have to click on field. Okay, you have to just click on field. And this is test field and grouping variable, you can see, and these are variable. So what I have to do, I have to, in test field, I have to like bring dependent variable. And what is dependent variable? HB, baseline, 3 month, 6 month, click here. Then in fact group, I have to bring group 3 code, because I have given 1, 2, 3, more than 2. Please click here. You can see it came here. Okay. Then what you have to do? You have to click setting. Please remember, you have to click a setting. And in setting, you have to choose customized test. Click customized test. Then what you have to do? You have to click Kruskal Wallis one-way ANOVA case sample here. When you click here, this multiple comparisons all pairwise highlighted automatically. And after that, there is no need to do anything. You have to click run. Okay. So sometimes if you want Hoses Lehman estimate for 2 samples, this is a estimate confidence interval, median difference and 95%. Sometimes you can click here. This is a median difference and it's 95% confidence interval. But for this, I will not click this and then click run. Okay. So click run. You will get this. You have to wait for some time. Then I have to do. Okay, I'm not getting. No issue. So you have to click this and you will get. I'll have to check this what happened. non-parametric because it must be over there. I have to click this field. I have to do, no issue. Okay. Click. It must be. Okay, I think there is some problem maybe. So it will come. Okay. So it will not come. I will say, okay, it has come. Okay. You can see here because I did 2 times, so it came 2 times. So it is also, you can see here, HB baseline to third month. Okay, HB base. Okay, HB base. So at baseline in within among 3 groups, there is the p value is 0.380. So it is there is a null hypothesis we cannot reject. So it is retain the null hypothesis because there is no significant difference. But for 3 month, okay, among groups, there is a p value is 0.003. So reject the null hypothesis. Okay. And for 6 months also, 0.001, reject the null hypothesis. But we are not getting this. Still we are not getting this between group. Which group? 2 groups. So what you have to do? There are 2 ways to do this. Okay. So what you have to do? You have to double click this. You have to double click to activate. So what you have to do? You have to double click this. So when you double click this window will appear. Okay. And this is for retain the null hypothesis. This is for baseline. This is like box and whisker plot. Okay. And this is a p value for that. But when you click this here, number 2, okay, left side, you can see hypothesis test summary. When you click this, so what happened? You can see this will come box plots. These are the 1, 2, 3 are groups. This is HB 3 month. You can see here in like y-axis, and this is for there is a significant difference. So what you have to do? There is one independent sample test view right side below this, just above the taskbar. There is an independent sample test view. So what you have to do? You have to click this and you have to click this pairwise comparison. Okay, here. So you have to click this pairwise comparison. So when you click this, so you can see here, there is a adjusted p value in this. This is a sample 1 and sample 2. This is a group 1 and group 2. There is a group 1 and group 2 comparison. This is p value and this is adjusted p value. SIG is p value and this is adjusted. ADJ means adjusted p value. 0.698. There is no significant. But 1 and 3 comparison, group 1 and group 3, control and diet and yoga group, you will get p value 0.001. This is a like non-adjusted p value, crude p value, but this is adjusted p value. It is 0.002. It is a significant. It is highlighted in yellow. And when you do like comparison between 2 and 3rd, means diet versus diet and yoga, then like crude p value is 0.27. It is significant. But you always take adjusted p value. Please never report this p value. You have to take adjusted p value, and this is 0.081. It is greater than 0.05. It means it is not significant. Although it is coming significant in non-adjusted p value, 0.027. But in adjusted p value, it is not coming significant. It means it is not significant. So significance between only 1 and group 3rd. That is control versus diet and yoga group. You will get in HB. Okay. So, and if you click on 3rd, that is a 6 month. You have to just click here, left side, click this. This will come. Again, this is box plot and this is asymptotic significant p value 0.001. Again, what you have to do, you have to click this, just there is a field, there is a test, there is a independent sample test view. You have to click independent sample test view again, always. Okay. then you have to click a pairwise comparison. So when you click this will come. Ignore this figure. No need to see this figure. Only just you can see this is adjusted p-value. Again, there is in non-adjusted p-value, 2 and 3rd group are coming significant. But in adjusted p-value, this is not coming. And you can see here, this is Born-Ferroni corrected p-value. In footnote of this table, you can see easily for multiple comparisons. So you have to report always if there is a significant in ANOVA test or Kruskal-Wallis test, then you have to need to do multiple comparison, or you have to apply post hoc multiple comparison or Born-Ferroni corrections. But please remember, if you get p-value 0.1 or 0.2 in ANOVA or Kruskal-Wallis, in 0.1 and 0.2, that is no significant. But please verify it. Sometimes in ANOVA and Kruskal-Wallis, okay, overall p-value is not coming significant, 0.1 or 0.2, okay, 0.1 or 0.2 or below 0.1 or 0.2. But in multiple comparison, sometimes it can significant due to some adjustment. So this is Mann-Whitney, and then Mann-Whitney test, and Wilcoxon, and this is Kruskal-Wallis. Now I have to go for, I will show 2 tests up to 730. That is chi-square and Fisher exact test and correlation coefficient. Okay. So I have to go for this. I can cross it. No issue. You can find out all these things. You can double click it, or you can copy paste over there. No issue. Then for I have to go for data sheet. Today there is no question answer because I don't have time for this. You can write down questions. We can do tomorrow. So for chi-square test, we know that dependent variable is categorical, independent variable is categorical. So for example, I want to find out the association between outcome. What is my outcome? There is a improvement or not improvement, okay, and versus control group or experiment group. Group may be 2, more than 2, okay, category. And also outcome or dependent variable is maybe 2 or more than 2. Categorical variable. Category, C. So we have to apply C, that is a chi-square. So what I have to do? I have to go in analyze. Then where I have to go? I have to go in descriptive statistics. I think in SPSS 30 also there is a descriptive statistics, and I have to go for cross tab. Please remember, I have to go for cross tab. So you have to click cross tab here. Okay. Then there is a row and column here. This is a cross tab dialog box you can see. So in column, please always put your grouping variable. So what is my grouping variable? Here is grouping variable group 2 code. So click this and then bring in column. Very good. And this is outcome variable. This 0 and 1. 0 means no improvement, 1 is improvement. I can see in my data sheet, you can see. Okay. So this is, so for 3rd month and 6th month, I will go for, because baseline I have collected data and I have seen there is improvement at 3rd month or 6 months. Okay. Then I have to click this outcome. Then I have to bring this variable in row. Then outcome at 6 month, I will bring this variable in a row here. Then please remember this on right side, there is a exact okay button. You have to click exact button. And please remember, always click this exact, and this is default setting, asymptotic significance, and you have to click always exact. Please make your habit for this chi-square test and click OK. Continue. Sorry, click continue. Then statistics, you have to click this statistics, click statistics here. Then please apply chi-square. This is a cross tab statistic. You have to apply chi-square. Okay, click chi-square. Leave other things here. No need to do. Okay. When we do McNemar, we will click here McNemar test. But for this, like we have to click chi-square. We'll continue. Then again, this is a C cells. Okay, you have to click this button cells. Exact statistics and cells. Use these three buttons. And then you have to click percentage. This is a percentage. So you have to click always. If you want column wise percentage or row wise percentage or total percentage, you have to click according to you. But I will click column percentage. Okay. Then click continue. And then click OK. So you will get this. Okay. There are two groups. This is a cross step. You can see here. This is a cross step. And this is you can see here data in 2x2 format, because there is a 0 and 1 and there is a control and intervention 2x2. So this is, you can read out this control group, the improvement. One is improvement. In control group at 3 months, only out of 75, only 12 got improvement. That is 16.6%. But whereas in intervention group, 26 improved out of 75, that is 34.7. So there is a, you can see here, there is a more improvement in intervention group compared to control group. But this is significant or not, we have to see this chi-square test. So please remember and please write down anywhere. Please this, okay? Please this sentence and what I speak now, you have to write down which p-value I have to take. So you have to see this. This is 0 cells have expected count less than 5. Footnote of this chi-square test table. 0 cells have expected count less than 5. So please remember, please write down, if there is 0 cells, then I have to take a Pearson chi-square value. This is value of Pearson chi-square. This is a degree of freedom of chi-square. And I have to take this asymptotic significance two-sided. This is p-value for this. So because here is a 0 cell, so I have to take Pearson chi-square. This is value, this is degree of freedom, and this is p-value, 0.009. It means this improvement difference is significant. Okay, so there is an association of improvement between groups. Okay, so we find out a significant improvement in intervention group compared to control group. Number 2 condition, if there is 1 cell, 2 cell, 3 cell, 5 cell, 6 cells, whatever cells here, 1 cell have expected count less than 5, 2 cells, 3 cells. So what you have to do? You have to take Fisher exact test value in front of Fisher exact test and below this exact significant two-sided, not one-sided. We prefer two-sided always. And this is p-value 0.014. It is also significant, but it is highly significant. It is just significant. But in which condition? If we find out here in footnote A, 1, 2, 3, 4, 5, 6, whatever cells, then we have to take Fisher exact test. Otherwise, we go for Pearson chi-square. Please remember this. Likewise, in 6 months, we can see this is improvement. This is 1 for improvement. 0 means not improvement. And 6 months between control and the intervention group. You can see here like only 21.3% improved in control group at 6 months, whereas 42.7% improved in intervention group. But this significant is statistically significant. This difference is statistically significant or not. So we have to see this chi-square test table. And again, we have to see 0 cells. Here we have to see this footnote. 0 cells, it means we have to go for Pearson chi-square value. This is the value of Pearson chi-square. This is degree of freedom, and this is asymptotic significance p-value. This is also significant. But if suppose I found 1 cell or 2 cell here, sometimes we got it 1 or 2 cells, expected count. Okay. So what is expected count? I will tell you tomorrow, only just example. Okay. No issue. Then this is Fisher exact test I have to take. So suppose I got here 1 cell have expected count less than 5. Okay. So I have to take this Fisher exact test, and this is p-value 0.008. So this is also significant and two-sided. Sometimes what happened, Pearson chi-square came significant, but Fisher exact not came significant. So what you have to do? We have to report according to these cells. This is corrected. Okay, this is corrected test, Fisher exact test. So if there is a one cell, we have to have report this test, even though it's not coming significant. Okay, please ignore this if it is coming significant. Oh, sorry, chi-square test or Fisher exact test. Last test for 5 minutes, I will do correlation coefficient, Spearman and Pearson. Pearson and Spearman rank correlation. So what I have to do? I have to go for, again, analysis, most famous button. I have to go for analysis. Then I want to see correlation, simple correlation, okay? Height and weight correlation. And we know that when height increase, weight is also increase. So it is a positive correlation. One thing is increasing, another thing is increasing, independent variable is increasing, dependent variable increasing, it means there is a positive correlation. What is negative correlation? One thing is increasing, but counterpart or other thing is decreasing. It is called a negative correlation. For example, if you have weight, so if you are doing like exercise daily, okay, you are exercise daily, so you will reduce weight. So increasing exercise, reducing weight, okay. And if there is a supply is less, so demand is increasing. Supply is less of any material, demand is increasing. There is a negative correlation, okay. So what I have to do for correlation? I have to go in correlate variable, analyze correlate variable, and I have to just click a bivariate correlate, bivariate, okay. So it is most famous button of bivariate. Please don't think about other button. You have to like see or think about only this command bivariate, okay. Click click this dialog box will come, bivariate correlation, and I want to do correlation between height and weight. So what I have to do? I have to put both variable in this variables. So where is my height? Here is my height. Click height and bring this height from here to here, and then weight, bring weight from here to here. You can do for age also, no issue, age, and bring age from here to here. We know that if age is increasing, height is increasing or not increasing, we want to see, okay. So but for this I don't want to do this. I will remove this age. No need to do anything. You have to click this correlation coefficient here. It is default Pearson, and if you want to see Spearman, you can click Spearman correlation coefficient. Even you can do Kendall tau correlation coefficient in ordinal variable, Kendall tau, but I don't want to because these are not ordinal variable, height and weight. So Pearson and Spearman, both correlation coefficient I can get within one click, okay. So click OK. You will get this correlation. This is a non-parametric correlation. This is parametric correlation. You can see Pearson correlation, and this is a Pearson correlation. This is R value, and this is SIG two-tailed. This is a P value, two-tailed. SIG means significance value. N is how many sample? This is a 150 sample. Okay. This is a non-parametric correlation. This is a Spearman row correlation. This is a row value. This is a row value. And this is a P value, and this is N value. So see this. We can see in height and height there is 1. 1 means we know that height and height for similar value, same variable, always 1, 1.00, there is a perfect correlation. Always you will get 1. We can understand it, okay. It is 1 because same variable, 1 increasing, always same degree, that is also increasing, height and height. But when we see height and weight, so this is a Pearson correlation R value, okay. And there are 2 star, and these the footnote you can see, 2 star correlation significant at the 0.01 level to TELT. Okay, and this is p value 0.000. This is a highly significant. And when you want exact p value here, so what you have to do, you have to click this. Okay, you have to click this. You have to activate this, and then you have to activate this. This is exact p value you will get. 1.548 to E minus 18. E minus 18 means 0.00000015482. This is E minus 18 means you have to put 18 times 0, 17 times 0, because 1 point, 1 point, already 1 is over there, so you have to put 17 0, 0.0000. In R studio, you are getting a p value according to this 0.0000, something like that. Okay, so you will get p value if you click this, activate this. Like this, you have to double click, then you have to click this, you will get this p value. Okay, so this is p value. So there is a highly significant correlation between weight and height, but R value is 0.638. It is positive or negative? It is a positive value. It is positive value. It means height is increasing, weight in increasing. Independent variable increasing, dependent variable in increasing. It is, I think, moderate, something like correlation. When you want to see non-parametric correlation, same thing you will get out. This is a Spearman rank correlation coefficient rho value. There is something like, because there is a formula is different. So you will get R rho value is 0.655. It is also highly significant. P value is this. Okay, 0.0001. If you want to see exact P value, you have to double click it. You have to click this. This is also minus 19 also. It is more like 0.000000. Okay, so this is P value for this Spearman rank correlation coefficient, and this is for Pearson correlation coefficient. Okay, it's 7:29. Okay, thank you. If you have question, please write down. I will show this. I will save this. So what I have to do? I have to click this here. I have to click export. Then all visible. Then I want to click this here. Okay, I want to save this on desktop. Result 25th. Okay, then click OK. Click OK. Then it was saved. I can see here on my desktop it is saved. Okay, this is result 25. It is saved. I can open, I can see. Okay, thank you. It's 7:30, and as I told you that 7:30 I'll take class. There is no question answer today, and we have left today's simple linear regression and multiple linear regression. We will cover tomorrow. Okay, thank you so much. If you have any question, you can ask me, but we don't have time. Sorry for. You can ask me on my WhatsApp. Okay, thank you.
Thank you, sir, for the insightful session. And guys, you will definitely get today's recording, as the session was quite tough today. So thank you all for joining. And the question answer round, for the question answers, as sir said, please share us the question on the WhatsApp. We will reply it. Thank you, everyone. Thank you, sir.